Up till now, everything you've done has been in degrees. And you've learned that in a circle, there's 360 degrees. Now that 360 degrees is just an arbitrary number. Maybe someone chose that number because it breaks things up into a small enough number that's usable. But it's degrees is a measurement that is not connected to anything. Radians is another measurement for angles. And we realize that we have different measurements for different things all the time. Right? If I ask you how tall you are, Guillermo, how tall are you? 184. Okay. Peter, how tall are you? You have no idea. Cameron, how tall are you? 5'7". Okay. So Guillermo is 184, a beast of a height, compared to 5'7", this little tiny number. So we have giants and midgets at the same time in this class. Why are the numbers so different? Because you've got feet and inches, you've got centimeters, right? They're different measurements for the same thing. And so we have to get used to that, not one person is way bigger than the other person, but we have different measurements for the same thing, right? If I would all of a sudden, if someone would say, you know what, you can choose what currency you would like your salary in today, I probably wouldn't choose Canadian dollars. Because I could probably figure out a currency that's worth a lot more and get paid a lot more pounds. American dollars worth more. But we have things that measure the same thing. They're both currencies, but have different values. Just like feet and inches and centimeters are different ways to measure length. Radians is just a different way to measure an angle. So up till now we've had degrees, right? Degrees, 360. There is gradients. Someone said, well, if 90 is such a weird number, why don't we split everything into 100, so have 400 gradians in a circle instead of 360 degrees? Well, that was another measurement. That one didn't go very far. But once you get into higher level math, we start using a radian. And the nice thing about a radian is the radian is based on an idea. It's based on a relationship within the circle. So what do I have here is my special radian teaching tool. What kind of triangle is this? First of all, you know this is a triangle? Yeah, is it good? Okay. Didn't know how far back I'd have to go. No, just kidding. So this is a triangle. What kind of special triangle is this? It's equilateral because all the sides are the same length. So if I drew a triangle, whoa, there we go. There's my, I'm going to try and make a circle. This may or may not work well. Okay, that circle that I just made has the same radius as the length of my triangle. So if I put my triangle on there that's equilateral, it was this triangle like this with 60 degrees. 1 radian, the definition of what a radian is whenever the arc length, which we just developed a formula for, whenever this arc length is the same as the radius. So what I'd have to do with this triangle is I would have to push it down a little bit until it matched, this curve matched on the outside. If I did that, what happens to the angle? It gets a little bit smaller. And this angle right here, we call that 1 radian. It's approximately a little bit less than 60 degrees. We're going to get more accurate than that, but that's where we're going to start. Does that make sense? That it would be a little bit less than 60 degrees, because as soon as I push down on this side of the triangle to make this the arc, this angle right in here gets pushed down as well, making it a little bit less than 60 degrees. So the definition of a radian, 1 radian, is the angle when the arc length is the same as the radius. So if that arc length is the same as the radius, we call that 1 radian. Well, if we really want to figure out what does a radian exactly equal compared to what we've dealt with before, which is degrees, we might ask the following question. How many radians? We know there's 360 degrees in a circle. How many radians in a circle? 6 and a little bit. And how do we know that it's 6 and a little bit? Well, because if each radian is the same as 1 radius along the outside, we already know our circumference is 6 and a little bit radiuses. And since each radius along the outside of our circle, here's my circle, here's 1 radius, here's another radius, here's another radius, here's another radius, another one, and a bit. Since there's 2 pi radiuses in a circumference, there are 2 pi radians in a circle. Which then allows us to do some comparisons. Because if we make a chart, and on this side I have degrees, well, 2 e's in degrees, and on this side I have radians, what are 2 things that are equal? 0 and 0. Good one. 0 degrees is equal to 0 radians. 180 degrees is equal to how many radians? Pi radians. Why? There's one I want you to get before these two. Well, 0 is not bad, but the whole circle is 2 pi. Whole circle in degrees, 360 degrees. Okay, I'm going to, I'm not going to do that. I am going to, are you okay if I change the order and put this one there? Is that okay? Okay. I'm going to give you one. I want you to tell me, I'm going to give you 90 degrees. I want you to tell me how many radians that would be. Half of pi, or pi divided by 2. Excellent. Let's see if we can, harder one. How about 60 degrees? Pi over 3. Pi and a little bit. Someone who said pi over 3, can you tell me how you got that? You took the 180? Did someone say they took the 180? And you said, how do I go from 180 to 60? I have to divide by 3, right? Because it goes in 3 times. So how would I do this? I have to do the same thing. Divide by 3. So this one here, 180 degrees is equal to pi radians, becomes really important. Because the next thing I'm going to ask you is one that's harder. How about 1 degree? Yes. See how if I want to go from 180 down to 1, I'd have to divide by 180. So if I have to divide this side by 180, I get pi over 180. How about 1 radian? No, pi radians is 180 degrees. 3.1415 blah, blah, blah is 180 degrees. But what's 1 radian? 180 over pi. Take your calculator out. Find out as a decimal what's 180 over pi. Because right now we're hoping to get a better definition of 1 radian is approximately a little bit less than 60. Is 57. All right. How about we go 57.3 degrees as a pretty good estimate. It's interesting that it actually squishes it that much. It's a little bit less than 60. You might have thought, oh, 59, 58, but it's actually 57.3 degrees. Now, again, the reason why radians are used more is because it actually is connected to a circle. It has meaning, whereas a degree is an arbitrary amount. A radian is connected to its radius and has a meaning with the circle. So with this, on your next page here, you have that shaded part. There's the shaded part. And that shaded part says these things that we've just found out. We figured out that 1 radian was 180 over pi. And 1 degree was pi over 180. Because one of the things we're going to do a lot of is change from radians to degrees and degrees to radians and get used to them and start to know certain ones. For example, you see 90 degrees, you're going to think, oh, that's pi over 2 radians. 180 degrees, that's pi radians. So this one is really, if you put a box around that one is the really important one. Because if you know that one, you can figure out all of the other ones. And if you can't remember that one, you should be able to remember this one, because that's how many are in a full circle. And if you know 360 is 2 pi, you should be able to figure out 180 is pi. And if you use the proportional reasoning, I cut both of them in half, I find the next one. I cut both of them by 180, I figure out what 1 degree is. I cut both of them by pi, I figure out what 1 radian is. Now, this morning, we developed a formula. We developed the formula for arc length in degrees. Wow. And I don't know why they use the letter S for arc length. Maybe because A stands for area so many times. So the formula we created was the arc length was theta out of 360 degrees multiplied by the circumference. And I'm going to leave it unsimplified like that because I think that's the easiest way to remember it. It's just a portion of the circumference. And that formula is not on your formula sheet. What we're going to add right now is we are going to add the formula in radians. So if you, instead of thinking in degrees, you wanted to figure out your arc length in radians, you're still thinking proportionally. Your arc length is going to be theta, it's the angle you chose, but instead of 360 degrees, what am I going to put? 2 pi. and then multiply that by your entire circumference. Yeah, and that one is so, because it's so easy to see that this and this would simplify, this one is on your formula sheet, and it looks just like that. Becomes a really simple formula. But I still like this formula because it tells you what it means. But I think for this formula, it also tells you what it means. Because if I make a circle and I say the radius is 7, and I ask you, what is the arc length from there to there if my angle is 3 radians? What does 3 radians mean again? 3 radians is a relationship. That means there would be 3 radiuses around the outside edge, and if I did that, 7, 7, 7, this length would be 21. Can you see how the formula has that? The angle is 3 radians, the radius is 7, and we get 21, because that formula is saying your angle in radians is exactly how many radiuses are around that outside edge. So this simplified formula, I don't mind, because they both have meaning. I think this has meaning, and this has meaning, and it's neat to see how this connects together. So there's your arc length formula for radians.